Cool, yeah. So a little bit about myself. My name is Keen. I work at Google in Sunnyvale. I'm in the part of the Angular tooling team, and I'm from Seremban. Is anyone from Seremban here? Cool, go Seremban. Okay, so let's talk about build performance and just build in general. This is something that we have been focusing on because we realize, Angular users are so diverse. There are hobbyists who develop very small projects to enterprises who develop really, really large applications. Take a guess how many inside Google, the largest project that we have, take a guess how many components there are. It's in the order of thousands. So I think the last we counted, it was about 2,500, so 2,500 components in a single application. And let's do something fun. So let's talk about build performance, but let's do a live survey. Can you go to this website and then you can answer questions? And once I start the quiz, and then the results will be shown on screen. So let's give people about 15 seconds. I just want to see how many people are interested in the topics that I'm going to cover later, so I can know which topics I should emphasize more. Okay, so is everyone good? Cool, all right. Let's start the quiz. Okay, first question, do you use Angular CLI? Woohoo! I'm in the CLI team, by the way. Or maybe the first question should be, do you use Angular? Well, cool. So 54 of you use Angular CLI, so that means you use Angular is a battery-included framework, which means everything kind of works out of the box. And we go through great pains to make sure that the Angular CLI is a seamless experience, which means all you have to do is to do your scaffolding. All you need to do is engineer, to build, ng-build, and then to serve, ng-serve, right? Cool. So let's move on to the next question. Do you think your build is slow? It's kind of funny because when I asked this question just now, I think only a few people raised their hand. And okay, I think we do have a general consensus here. Like people do think that their build is slow, right? But slow is a relative adjective, right? It's slow relative to what? So it really depends on the how slow you think slow is, right? For me, I might think that 30 seconds is slow. For some other people, they might think that 2 minutes is slow. This is kind of fun, actually. Okay, cool. So it takes about 2 to 5 minutes for most people to do a build. I don't have a question here, but I'm also interested in incremental build, right? Because say, for example, you are working on an application, you make some small changes, and you want to see how fast the changes get reflected on your browser. So this is a pretty uniform distribution. I think the reason is it depends on how big your project is, right? It doesn't make sense if your project has 10 components and it takes more than 5 minutes. So this is the final question. How large is your project? Cool. This is really fun, and I think there is a lot of insight to be gained from here. So most of you are in the order of tens of components, hundreds of components, nothing near the scale of what we have inside Google, but still you have the same problem, which is a slow build. So this is a problem that we have heard a lot from the users, and also internally at Google, because of the way the infrastructure is so different, that things are done in a very different way. So today I would like to maybe explain a little bit more about the process of how build is done inside Google, and also what you can do, a sneak peek of a future technology that we can use to actually hopefully speed up the build and in general, people think that build is a pretty painful process, but hopefully with what we are working on, we could make that experience a lot better. Cool. Cool. Thanks for the feedback. Okay, let's jump back to these slides. Okay, so let's talk a little bit about the build process. We know that for a lot of you, the build is slow, but fundamentally, why is it slow, right? We got to gather some data and look at the fundamentals building blocks of a build to determine why is it actually slow. This is a very typical layout of a very small Angular application. I hope most of you are familiar with this. There is a component which consists of assets like HTML, CSS, TypeScript. They get bundled together under a module, and different modules get bundled together under like a main or an app module. So this is very typical for a front-end engineer, right? Let's take a look at, so what we call, when we talk about a build, we have to consider what is a compilation unit. What are we actually building, right? It could be the entire application itself, or it could be one small part of an application. So in this case, I'm just going to focus on this one small part, which is a slice of the build. In this, we have some inputs and some outputs. The inputs is what we have in the components, TypeScript file, HTML, CSS. And then there's a black box, kind of like the compiler piece, right? This is what the inputs get fed into. And out of that, we get declaration TypeScript files and also JavaScript files. This is, in a very simplified model, this is one slice of the build. And you can imagine this thing happens many times for different parts of your application. And finally, all of them get assembled together to become a full, what we call a binary, or like what you actually ship to users. Now, this, if you are a back-end engineer, which I'm kind of like a back-end engineer, in Google we use Golang a lot for our back-end server. It's a very similar type of structure. When it comes to code, there are individual pieces of files, and then they get grouped together to be a library. Different library gets assembled together, and it becomes a binary. So what do we see from here? It's a very similar kind of structure. And in this case, what are the inputs and the outputs? The inputs are the Go files, the Golang files. The black box is the compiler, and the outputs are the executable itself. So do you spot like the similarities between, even though it's a front-end, Angular is a front-end project, and then you have a back-end server, but the build process is very similar. And the difference between what we look at just now and what we have here, the different piece is basically just the black box, just the compiler piece, right? So what if this is a very ambitious goal? What if we can use a same piece of software to build both our front end and our back end, right? Because conceptually they are very similar. All we need to do is switch out the black box, switch out the implementation, and let the build system takes care of the dependency, which means what goes into the black box and what comes out of the black box. So this is what we call an action. We have some inputs. There are some black box, which is implementation. Each of the black box have a different implementation, and then we get a different set of outputs. And every set of outputs get fed into another black box, right? Say, for example, initially, when we compile the components to be a module, each of the modules now becomes the input for another black box so that we get the entire application. So in this case, back to the example that I showed before, how many actions do we see here? If a compilation unit is a module, so first we're going to compile the smallest piece, which is module A. This is the first piece. And then we're going to compile module B. Once these are done, then we can take the outputs of module A and module B and feed it into another black box so that we get the entire application. So there are three main actions here. What we realize is that, do you think module A has to be compiled after module B or before module B? Right, yeah. Yeah, it's a trick question. So they are mutually exclusive. So they are on an independent path in terms of the build graph, right? So in essence, really build is about managing the dependency graph. And a build graph is just a definition of what goes in and what goes out and how the order of it is defined. And it also allows us to know what has changed and what has not changed so that we don't repeat. So imagine if, back to this piece, imagine if I change something in component 1, conceptually, I don't have to recompile module B because nothing in module B has changed, right? So the build graph keeps track of all this information and it knows exactly what to build and what not to build. And let's look at another example. This is slightly more involved. In this case, the Angular application uses Sass for style sheets. So it has, we first have to compile the Sass. These are topological dependencies. Yeah, so first it has to compile the Sass files, and then the Sass files get fed into the Angular compiler for the Ng module, and then finally, in a more elaborate, like a real-world build process, the final piece is the bundling part, or some people like to call it tree shaking, and then the minification. So in this case, action 1 through 4 can be executed in parallel, right? And yeah, so if you understood those concepts, you have basically understood what Bazel does. All it does is a way to keep track of inputs and outputs, and a way to tell the computer, to tell the build system what the black box is and how it is implemented. So Bazel is an open source project developed inside Google. It has been used internally for more than 10 years, so it has gotten a lot of abuse over the years, and it has proven to work very well. The black box that I mentioned is an extension of the build system. Bazel itself has no notion of how do I build Angular, how do I build TypeScript, how do I build C++. It has no knowledge of how all those different pieces get built, but all it cares about is the inputs and the outputs, because it knows if I feed this set of inputs to the black box, and I get the other set of outputs in return, and then what is the next step? Bazel knows how to coordinate all these different pieces, but it has no knowledge of how to actually implement the black box. This is why it is the rule author to define the implementation of the black box. And the author writes such rules using a language called Starlog, which is kind of like a dialect of Python. If you know Python, you know Starlog. And Bazel is known to be fast, really fast, correct, and reproducible. What do I mean by correct? So imagine if you have ever used make or CMake. Has anyone of you ever used that before? No? Okay. So imagine if you have to build something and occasionally the build doesn't work, or say, for example, you do yarn install, and so sometimes the node modules folder somehow it got messed up. So you got to delete the node modules folder and then reinstall yarn or npm. So correctness is what guarantees that we don't have to ever undo what we have done before. So in a case of make or CMake, that means you never have to actually run make clean or anything that erases what you have done before. Bazel, because it has such fine-grained knowledge of the dependency graph, it guarantees that when you change an input, the resulting output will always be the latest and the most up-to-date. And the last bit of Bazel is reproducible builds. Does anyone ever have the experience where you deploy something to production, and a week later, you found that there's a bug in production, and now you got to reproduce the build that you deployed to the production server. So you kind of like look at the commit, hopefully you tag it, you check out the commit, and then you build it. But then you realize that, oh, actually, it works on my computer, right? I think a lot of people have the same kind of experience. Even though you check out the same code, but you may not be able to reproduce the exact same bug that you see in production. This is why Bazel takes care of not only the build, but the environment that the code is built in, so that every time, no matter what machine you run it on, whether it's in the cloud, it's on your local machine, it's on your workstation, you always get the same build when you check out the same branch of the code. Remote build is something that I'm going to talk about later, but because Bazel is able to identify all this independent path in the dependency graph, it is able to execute every path in parallel, subject to the constraint of computing power. And just like the example that I mentioned before, if I change something in the component in module A, Bazel knows that nothing has changed in module B, so it doesn't actually, everything in module B has been cached. So Bazel knows that it does not have to redo all the work. And the best of all, Bazel is open source. If you're interested, the website is bazel.build, and it supports OS, Mac OS X, Linux, and Windows as well. So that is all about Bazel, but what has it got to do with Angular? There is, so today I mentioned that the CLI is kind of like a battery-included framework. So the CLI is how we actually ask users to build, we recommend users to build their application, and all the internal logic of a Webpack and minification and whatnot is wrapped inside CLI. But why do we want to introduce Bazel into this mix? It's because for enterprise users, the solution that is provided by the Angular CLI is just not scalable enough. And the CLI is actually not used inside Google to build projects, to build internal projects. This is because an Angular application inside Google has to work with so many other infrastructure that do not work well with the very confined way that is done externally. So internally, the CLI is not used to build, but it is used to do scaffolding for the code. And we are hoping that with Bazel, it's going to be a lot easier to configure your project. A lot of people, if you ever have to deal with a custom Webpack configuration, you know how painful it is. So we hope that with Bazel, it's easier to do such custom configuration. And the best of all, because everything is wrapped under the CLI, if we do switch to Bazel, we want users to have a seamless experience, and that means you should not notice anything that has changed before. And this is enabled by the builders API that we introduced in version 8. This is how things are done today. When you do ng-build, internally it invokes the Angular devkit build Angular package, and that knows exactly how to do all the minification and whatnot. But imagine if we could switch the builder out and use another kind of builder, which is something that I've worked on, is the Bazel builder. We could do everything the same way before. Like you don't have to learn anything new. ng-build still works, and ng-serve still works, but then we have actually switched the engine of the build pipeline. Right. So this is just a quick introduction on how you can get started with the Bazel builder. If you are using the Angular CLI, make sure you download version 8. It requires the Angular Bazel schematics, which is also version 8. And when you create engine, you can use all the existing commands for creating a new project, or you can add the Bazel builder to an existing project if you want to try it out. But there is caution to this, and I'll mention it sometime later. Because the caveat is that you don't get instant performance gain for free, right? You basically, the way Bazel knows about such fine-grained dependencies is because we tell Bazel exactly what the inputs and what the outputs are. So this is a part that the users have to tell Bazel. And because we want users to pick up Bazel easily, what we have opted to do is that we kind of like wrap all this configuration, all this magic behind the CLI. So if you ever want to get a powerful feature out of Bazel, you might have to eject the Bazel files. By default, they're hidden by the CLI. And of course, if you try Bazel today, we also made sure that there is an option to revert to the previous workflow. Okay, so this is the part that I hope goes well. I'm going to do a demo of a brand new Angular project that uses the Bazel builder. Okay. Yeah, so I just want to highlight that if you do ng-new, all you have to do is, you have to first install the Angular Bazel package, but all you have to do is just pass in this new collection, and you will see that it actually builds with the Bazel builder. Okay, what I've done here is, can I put this? Is this big enough, or should I make it bigger? I think I should make it bigger. Okay, any questions so far before I jump into the demo? No? Okay. Let's see, 3.-i node modules. Okay, so this is what we have in a project that is configured for Bazel. We see that there is a angular.json, which we are familiar with, but then there is also an angular.json.bak. This is a backup file in case you want to revert to the original workflow. The thing that I want to point out is that let's look at the angular.json itself. So, and compare it to the backup file. This is what we have today, the Angular DevKit package. And if you create a new project with the Bazel builder, you get a different kind of builder. It's the Bazel builder, and it's this line right here. Okay, so now let's just do the familiar command, ng-test. So this is running Bazel now. Okay, it says, okay, the test is cached, and it passed. This is because I have ran the test before. So let's make it fail. Let's go to this file. Originally, this is what it would say. Okay, this is how it is, a plain hello world application. So it says, welcome to demo. Let's make it welcome to ngmy. Oopsie. Save it. Okay, yarn, ng-test. Okay, it failed, right? Obviously it failed because I changed the title and then the assertion fails. Now let's change back to demo and see what happens. Cool, and now it passed. And what if I run the test again? And you can see that it actually didn't rerun the test because it has cached the output, right? So this is the one part that I want to show because Bazel by default caches all the inputs and outputs, and if nothing has changed, it would not actually rerun the test. It would not do any additional work. So there is one final demo that I want to show, which is let's get back to this example. And with 5 minutes, let's see if I can get it going. What I want to show is the parallelism of Bazel and how powerful that is. Okay, so in this folder, this is not an Angular folder, but then I have 3 files here. Bazel demo. Okay. So first, ignore the Bazel -- stuff, but then there is a build file. Okay, and then there is a test file. So this is kind of like my test script that I'm going to exercise. So this says sleep for 3 seconds, and then echo test pass, right? Okay, I'm going to execute it. Test.sh, 1, 2, 3, and then it says test pass. Okay, now what if we ask Bazel to invoke this test? Assume that this is like an assertion test. What if we ask Bazel to invoke this test? So every test needs a name, so I'll call it test1. And then it needs a source. This is a Bazel configuration, so it's a test.sh file. Okay. Now, what I'll do is I'll call Bazel build // ... So this means I want to, Bazel tests. I want to test everything that is in this package. How long do you think the test is going to take? Any answers? 3 seconds? 5 seconds? 10 seconds? Right, exactly. It took 3 seconds to run. Okay, this is because, well, obviously, it slept for 3 seconds and then it ran the test. Now, let's run this. I'm just going to create 4 tests now. 3. Okay. Okay, now how long do you think the test will run? 12? 4 times 3? 3? Okay, let's run it and see. Yeah, so you see, it only runs 3 tests, and it runs 3 tests in 3 seconds, which means the tests are run in parallel. Bazel inherently knows that there are no other dependencies of this test, so they all run in parallel. Okay, now let's just go berserk and make it 8 tests. 6, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8. Okay, how long do you think it's going to take this time? Okay, let's run it. Okay, it is running 4 tests because 4 of the tests has been cached before and the input have not changed, right? So Bazel inherently knows that I have 8 cores. I have 4 physical cores and 8 logical cores on this MacBook Pro. So it knows that it can run 8 tests in parallel. But now see what happens if we run this one final test. How long do you think it's going to take? 6? Okay, let's see. It is only running this one extra test that I just made. It is because every other test has been cached before. And now let me just disable the cache. No use action cache. Okay, how long do you think it's going to take this time? Right, so we see that it is running 8 tests right now, and then it is running this one other test. It is because in my CPU, so I have 8 cores here. Oh, yeah, I have 8 cores here. So Bazel is very powerful, but it does run into the limit when the number of CPUs, the number of tests exceeds the number of CPU. And why stop there? This is why we have remote execution. Imagine you can actually outsource your build to the cloud. And inside Google, we spin off hundreds of thousands of CPU to run the build. And everything can be executed in parallel. And best of all, everything is cached, including the cache itself. So the cache is shared with every user. So nothing has to be redone. As long as one user has done it before, every user gets the benefit. And this is why Bazel is powerful. And it is why we think there is a lot of value in bringing it to the external community. Cool. I hope you enjoyed the talk. And if you're interested in any of the things that I mentioned, please feel free and come talk to me.